Class is now starting. All attendees are in listen-only mode.
Hello, and thank you for joining. I'm Trevor Martin, a Senior Marketing Manager here at Cygilant. Today's webcast is entitled Building a Mature Cybersecurity Program. Our speaker today is Neil Weitzel, our Director of Security Research here at Cygilant. Neil has over 10 years of professional technology experience in a variety of information technology roles, ranging from user support to advising security managers. Neil is an expert application penetration tester and a trainer, and he's an active member of the security community, delivering lectures at DEF CON, OWASP, security meetups, and other events. As a reminder, all attendees are in listen-only mode. If you do have questions as we go through, please use the Q&A section of your webinar, and we'll do our best to answer at the end of the session. With that, I'll hand it off to you, Neil.
Hey, thanks, Trevin. So yeah, just as Trevin said there, if you do have any questions throughout the presentation, feel free to use the chat down below, and I'll also have some polls and questions to try to help you guys stay engaged throughout the presentation. But I do thank you all for joining us today during lunch, and without further ado, I'll dive into a little bit about building a mature cybersecurity program. All right, so the key takeaways I want you to take away from today are cybersecurity program activities that you can perform, or ways that you can build them into your current program to mature your program and what activities you're doing currently, as well as some common pitfalls and questions that most cybersecurity programs engage. Later, I'd like to do some Q&A with you guys, so if there's any questions towards the end, you can always hold those, or throughout the presentation, feel free to type those in the chat. We'll try to get to those immediately. All right, so first, let's justify the case for having a cybersecurity program. A lot of times, we try to bootstrap this or get this kind of involved within our IT teams, or try to loop this into our policy office, things like that. However, having a dedicated team is pretty imperative to having a mature cybersecurity program. Some of the ways that you can do this to justify this to whomever that may be, your management, the rest of your team, and stuff like that, is the first step is, nobody wants to be the next headline example of, a breach or a data breach or some sort of, ransomware attack, things like that. As we know, that can cause a ton of brand degradation. Potential clients, your clients currently may leave you or not want to do business with you anymore. Of course, there's always legal ramifications. Most of us fall under some sort of regulatory data protection commission, and that could cause some sort of fines or additional audits on a more regular basis. And then, of course, lawsuits. Whether you win or lose, those can cost a lot of money for any company who has to undergo that type of situation. And then, of course, there's the remediation cost of finding something or having to go through some sort of security breach. Oftentimes, having to do that in production means long hours after a breach has been discovered, or having to work to build this into a production environment, as opposed to trying to find something earlier on in your design or development phases of a solution. And if we can find and kind of keep a monitor on those things earlier on, or before they become problematic, that can of course save us tons of time, those legal ramifications, and any of the brand degradation. Similarly, lots of times your management and board want some insights into the risks that are involved inherently by having some of the data in our software. This could be, what are the critical data areas for us to do business as a company? How do we classify our data? Do we have confidential data? Do we have data that's only for internal use? Do we have things for public consumption as well? How do we access that data is really imperative for them to understand what software systems, networks, individuals actually can access that data. How do they access that data? And what are we doing to make sure that it's not going to be misused in a nefarious sense? The way I like to look at this is kind of, what is the worst case scenario with regard to the risks? What happens if, most ransomware attacks that we've seen today or to date this year can revolve around the entire data on somebody's systems being encrypted so the company can't access it. Maybe there's a breach where somebody gets into the systems and does something to affect our tool chain, so we're putting out software with malicious code in it. Perhaps we have a data leak as well, where we're actually just like giving out client data. So maybe these are some worst case scenarios. And so understanding what those scenarios look like can be some really good insight into what that risk truly is for us as a company. And then we can back that into some of these areas of, all right, well, where do we put this in terms of what is the data that's confidential, what is internal, what is public, what software systems, et cetera, can actually access these areas, and how do we make sure that those are protected? This is the type of risk that would really help, some of the senior level management buy into building a software or a cybersecurity program. Also, if you are working with clients, or you have lots of stakeholders within, your technical systems, you want to give those individuals a peace of mind. Lots of times clients may ask you like, well, how do I know that your systems are secure? Well, having them understand that you have a dedicated cybersecurity program, that you do various activities throughout your development, design, and implementation phases is going to help them know that you actually care about security, care about them, their information, and what you're doing to protect them. Similarly, your management will have some of the insight into what's necessary for those reviews and audits. So that could be, things like your PCI DSS, your HIPAA, high-tech areas, and having some of that information readily available that can show how you're maturing that program or taking care of your client's data over time, doing the necessary due diligence readily at hand with a dedicated cybersecurity program can arm them with the data that's necessary to kind of keep your auditors happy. Similarly, if engineers can focus more on features and what they're implementing, they know that their solutions are tested and monitored by some security folks or individuals. And then also the support teams, with the help of like a cybersecurity program, can have some policies and standards that they can fall back on. So when they have to support somebody or explain that this is why we have a passphrase instead of a password, or we have complex password policies, this is why we have these in place to keep you secure. And they can understand that from the guidance perspective of having some of these policies and procedures in place, so that therefore clients can understand that you're also doing the due diligence to make sure that they are secure. I believe I have a question here for you guys on this one. Poll. Sorry, the poll is not available apparently. All right, the poll was going to be what kind of stakeholders we have in the audience today. Sorry. All right. Similarly, and this is my least favorite way to justify the need for a cybersecurity program, is the compliance area, the check the box. This here is an eye chart, as you can see. Most of us fall under some regulatory commission where we have to make sure that we're doing the necessary due diligence to ensure that our client's data is secure, that we're handling information in a very secure manner. However, when you have to rely on this as your reason for making a cybersecurity program, oftentimes that can lead to doing the bare minimum. You just want to do enough to check the box. So this is why it's kind of always my last resort for trying to justify a cybersecurity program. I usually do try to rely upon the previous ones mentioned, as we can see here. We want to make sure we stay out of the headlines, understand the inherent risks that we have with the systems that we're using, provide a peace of mind for our stakeholders, and having that dedicated program gives the opportunity for the other stakeholders to focus on the areas that are most important to them, such as engineers on features, support on usability, management on areas for improvement, etc. All right, so now let's take a different look at this here. So now that we've justified our program, let's look at some of the activities that we can perform. Most of the time when we're developing a solution or trying to implement something in our company, the root cause is a business need. We need to accomplish something, and we want to try to automate it or put a system behind it so that we can provide that at a very scalable solution for all of our users. Then we usually try to build that solution, test it, and then there's usually some maintenance, updates, things like that. However, we can take another perspective at this, and this is where your cybersecurity program comes in. When we come up with those use cases for that business need, your cybersecurity program can take that and pivot around it and say, well, these are the abuse cases. This is how somebody may try to come at this solution with nefarious intent. Whereas somebody may be trying to access data, maybe somebody will also try to delete that data. Is that really a necessity for a business need, or is that just an abuse case? Similarly, as we look at building in some of these solutions, we'll want to identify known vulnerabilities in some of the off-the-shelf or developed solutions, and we'll dive into that in just a few. Similarly, as we talk about testing and deployment, there's also security testing. A lot of times we focus on business logic testing or testing that makes sure that the features are implemented correctly, but we're not always looking at the ways that somebody may try to misuse or abuse the software. And that's where those abuse cases can come into play with the security testing we do. Also, as we have the maintenance, patching, and updates areas, we also have to review that and audit those. So how often do we patch our systems? How often do we scan them for vulnerabilities, for updates, and things like that? And then do we have some sort of audit record where we can provide that to perhaps auditors, stakeholders, things like that, to know that this information is readily available at request. So let's take a little bit closer look at this business need here. So perhaps we have an individual who wants to, I think that there's a pointer. So let's say we have an individual here, a user, and the new business need is they want to be able to use their laptop or telephone to access a piece of software that maybe has some information on a back-end database. Let's call these some like sales records or something of that nature. Well, if we want to take the cybersecurity approach to this, all right, so we know that we have some abuse cases here. Well, if we have something that we can do with the end user, maybe we're going to social engineer them into clicking a link, providing some information that's erroneous or unnecessary to the program. Similarly, if we have devices like the cell phone or laptop, maybe an attacker is going to infiltrate that device. Also, the exploitation of the software itself. Are there vulnerabilities in the software? Is there cross-site scripting, perhaps SQL injection, things of that nature? And then lastly, a data breach. If we're able to reach that final pivot into the server, how are we making sure that that data isn't going to be exfiltrated, leaked, or encrypted by some nefarious user? So then we come into the build and maintain phase after we've looked into our use cases and abuse cases. The build and maintain area, usually you have a developer or an engineer who's going to either buy some software or build some software, and then that's going to get promoted to some sort of test area where we can make sure that the implementation, the solution fits the business need and all the features that everyone's requesting. And then we upgrade that into the production area. However, again, we want to take the cybersecurity program view here and see that, all right, not just testing and reviewing, but for the person who's actually implementing these, they're going to have some training to understand what the risks are, what those abuse cases are, and understand the policies that would go with that as well. Perhaps this is to make sure that all of our solutions support some sort of encryption over the network. We want to use like TLS 1.2 or something of that nature to ensure that the communication between our solution and the end user is secured and that nobody can sniff that network traffic. So maybe that's a policy, and we want to provide training to these individuals to understand what those policies mean, as well as so they know how to implement them appropriately. Now, when they start looking at these solutions here, whether they're building it in-house or whether they're actually buying it off the shelf, we want to make sure that we research and investigate known vulnerabilities for these pieces of software. Whether we're looking at building this in-house and maybe we're going to use some like Angular JavaScript, maybe we want to look at, say, what version are we using here? Are there any known vulnerabilities? How are we going to make sure that we provide some sort of security controls around those vulnerabilities to ensure that they are secure? Similarly, if we're buying something off the shelf, are there any known vulnerabilities in that as well that we need to consider? Can we work with the vendor to make sure that they close those for our needs, whether it's for regulatory purposes or that we're just doing our due diligence to make sure our clients are secure? After we have most of that stuff in place and we upgrade our solutions into the test area, we can use those same abuse cases that we came up with on the last slide to ensure that those test cases or abuse cases are tested. So, if we want to make sure that, again, for example, all of the communication happens over a secure channel, in our test area, we can test the connection between, our client and our test server to make sure all of that network traffic is encrypted appropriately. After we've done all of that, testing and hardening of our software, then we can deploy it. And from the security perspective, we ensure that the deployment is kind of analogous to what we did in the test area, and constantly audit it in terms of, all right, there's a new patch out for perhaps the AngularJS that we used to develop this, or perhaps the solution that we bought off the shelf has a new patch out. How are we making sure that that gets deployed in a regular religious sense? Does that happen weekly, monthly? And do we have reporting or audits on that so that we can provide that to individuals upon request? So this kind of comes into where we have security controls. So our security controls at the user level may be the training and standards and policies that we talked about earlier. And at the endpoint, antivirus software, device logs, things of that nature. And when our devices connect to our software, maybe we have network firewalls, gateways, or proxies. And at the application level, we can have web application firewalls, vulnerability scanning to look for particular types of vulnerabilities in our software, application logs that we either write ourselves or perhaps the solution we buy off the shelf has those built in. We have network devices that may be, your switches or gateways, intrusion detection systems or intrusion prevention systems that can provide output as well. And then on the back end, maybe we have back-end service logs or server OS logs. So each one of these areas has a lot of output and a lot of security controls built in. And as you can see, that would be quite a lot for any one security team or one person to have to look into. Each one of these areas itself could be, a full-time job for trying to implement in, any kind of size company, as well as one that's scaling. So in order to scale this up, we have to look at how we're going to make sure that we can take all of this output in one area and kind of do some sort of correlation on it, do some sort of analysis on it in a greater sense. So there are lots of solutions to this, but our solution in-house is taking all of these information and putting them into our SOC View portal. This can provide, security monitoring from particular areas. So if you have, your security areas, maybe your antivirus software, your firewall, some of your intrusion detection systems, each one of these can filter into some of your security monitoring areas, and we can look for particular events or anomalies that would happen within your devices and say, all right, this is perhaps an intrusion or perhaps a nefarious actor. And we can fine tune that, and those types of kind of events can be used to identify threats within your network. This is a pretty complex area, so grabbing all of this information from multiple sources and correlating it can be really useful. Otherwise, you're just kind of looking at a pile of data. Similarly, you can do this from your vulnerability management areas. As we talked about earlier, perhaps you're doing some sort of vulnerability scanning, whether that's using some sort of tool like Nexpose or Tenable to scan your software, scan your solutions. And if that's the case, you can use that to correlate this with some sort of open vulnerabilities within your systems. And then lastly, as we know, most of the vulnerabilities and exploits that we see on the internet or in the cyber realm are due to patches missing. We can think of a number of recent security breaches that are just due to somebody not patching their systems or auditing their patch trail. So again, making sure that you have that necessary information at your fingertips can be really useful for identifying these types of vulnerabilities and making sure that you do the necessary things to patch your systems in a really religious sense. So hopefully from this little bit here, it's kind of giving you an idea of some of the activities that you could be performing, maybe some ones that you aren't performing, kind of how you can either bolster or bolden them with what activities you are doing or enhancing them. And then I'd like to talk about a few common questions here. So the most common question that I get asked with regard to the cybersecurity realm is, so where do we start? If we don't have anything in place, if there's nothing really already out there, where should we start as a program? And I usually say, well, understand your risks first. So understanding the perspective of these are the things of high value that I'm operating on as either a company, software, team, etc. These are the things that if we lost or didn't have, our business wouldn't be able to operate. And if we have those risks enumerated, we can start saying, all right, well, now what security controls are already in place there? Do we have that web application firewall in place? Do we have some sort of logging in place to make sure that we understand when something nefarious is happening, when an attack is going on within our systems? All right, but then the next question comes in, well, what tools should we use to identify those? Well, I try to say that there's not a right tool for the job as much as making sure that you have good tools. Yeah, there's going to be some tools that are better than others, and that takes a little bit of research to make sure that the ones that you implement are the correct ones for your solution. However, the tools should be a little bit more agnostic. You want to make sure that you have individuals that know how to use the tools, tweak the tools, and use them correctly in your environment. And then they can do that special fine tuning to make sure that the output of those meets the criteria that kind of fulfills whatever justifications you've used to build your cybersecurity program, whether that's identifying risks, making sure that we're compliant, things of that nature. And then, well, how do I know when my systems are secure? Well, inevitably, this is not a set it and forget it type of situation. This is going to be a constant arms race. Whereas as we patch new software, as we build in new solutions, develop new security controls to help harden our systems, there's always going to be new developing attacks. And so we have to kind of keep our finger on the pulse, or have a team that can keep their finger on the pulse of what's going on in the cybersecurity realm. And that's where having a dedicated team again can really help you kind of get that off the ground, as opposed to trying to build that in with somebody who already has enough on their plate, perhaps an engineer who's creating systems, and now they also have to kind of consider, well, what new vulnerabilities came into this Windows server that I'm setting up today. So with that there, I'd like to open up for a few questions from the audience if anyone has any. Cricket, cricket. All right, well, if there's no questions there, feel free to reach out to us. We'll be putting out more of these types of webinars and podcasts, as well as blogs regarding a few of these cybersecurity areas going forward. Hopefully this has whetted your appetite enough to kind of want to build out your cybersecurity program a little bit more, or investigate what areas you can mature further.
So thank you all for joining, and thanks again to our speaker, Neil Weitzel.